in which we have to plan an experiment. In this question, potassium sulfate is a salt which is produced when sulfuric acid is neutralized by potassium hydroxide solution. The correct amount of potassium hydroxide solution must be added to neutralize all of the sulfuric acid. Plan an experiment to obtain pure crystals of potassium sulfate from sulfuric acid and potassium hydroxide solution. You are provided with a common lab apparatus, but first, before like extracting or obtaining a salt, we should know what volume of acid is reacting with an alkali. So to know the volume of acid reacting with an alkali, we should always use a titration, a technique in which we are finding the concentration or a volume of unknown solution by the known solution. So first we have to do titration, and after carrying out the titration, here potassium hydroxide is reacting with sulfuric acid, which result in a formation of potassium sulfate. You don't have to write the equation. The equation is not having any marks here. The experimental technique which you will use, that is having marks, plus water. The equation must be balanced as well. When acid is reacting with an alkali, this result in a formation of salt and water. So we will put 2 to balance potassium. But what is the state? When you check the state, alkali is aqueous, acid is also aqueous, the salt which is formed is also aqueous, and water is liquid. So when you are mixing two solutions, and if there is no solid form or there is no colored solution form, it means that you cannot see anything. You cannot observe anything because potassium hydroxide is colorless and aqueous. Sulfuric acid is also colorless and aqueous. So it will be difficult to identify.
Put indicator.
Yeah. So we will use indicator. So what we will do first, example, we will take
Measuring cylinder.
using a measuring cylinder, take 10 cm cube of KOH. Potassium hydroxide by help of measuring cylinder. And transfer into conical flask. That is first thing. Then what we will do, we will add drops of indicator. But it's not like you don't mention just add drops of indicator. You should mention the name of indicator like phenolphthalein, methyl orange, thymol blue. It's up to you, but any specific name of that indicator. So add methyl orange or phenolphthalein. Then fill the burette with sulfuric acid. And in exam, do not write these formulas in the explanation. You will write the full sulfuric acid. I'm using the short forms, it's the formulas. So fill the burette with sulfuric acid and add acid from burette. Until indicator show a color change. Then record the volume of acid and alkali uses or used. Yes, you can add phenolphthalein. That's also right. So record volume of acid and alkali used for experiment. But repeat the experiment without indicator, because we want to obtain a salt from the solution. So if the indicator was there, the salt solution will be colored. And if I obtain the crystals of from the colored solution, then it will form a colored crystal due to the indicator color. So record volume of acid and alkali used for the experiment. Then repeat the experiment without indicator with same volumes of acid and alkali. Now we have a salt solution. So now we have a salt solution. How to obtain a soluble salt from the solution? The technique which we use, that is crystallization. So you will explain now crystallization. So heat and concentrate the salt solution. So we are heating it and then we are concentrating a salt solution. Then we will cool until the point of crystallization. And how we can check whether it reach a point of crystallization? So we can take a glass rod and dip in the solution. When we take out the glass rod, if solid form, then on the glass rod, it means we will reach a point, we reach a point of crystallization. That crystal, if we cool down the complete solution, the crystal can form. Reason for using this glass rod, because when you dip a glass rod, a small quantity of the solution is taken out from the mixture so that it can cool down quickly. Otherwise, if you wait for whole solution to cool down, it will take a lot of time, and maybe if you did not reach the point of crystallization, then you have to heat it again. So heat and concentrate the solution until the point of crystallization, then filter and dry the solid. Is it clear? The technique which we use to obtain the crystals of potassium sulfate from the reaction between sulfuric acid and potassium hydroxide. Any doubt in this? Is there any doubt? Another experiment question related to May June 2016, paper 6, variant 3. Okay, in this question, nickel sulfate, which is .6H2O, is a blue crystalline salt. Plan an experiment to obtain a sample of pure water from this salt. Your answer should include include a diagram of the apparatus, any expected observation, a test to show the presence of the pure water, and you're provided with a common lab apparatus. So basically, we have a hydrated salt here, and when we have a hydrated salt, how we can remove the water of crystallization is by supplying heat energy. But after supplying heat energy, the water will turn into vapor and it will escape. So not only we have to supply heat energy, we have to condense the water.
Fractional distillation.
Yeah,
Fractional distillation.
basically, like we have to condense fraction distillation when you're separating two miscible liquids. The distillation, it's the same thing, but in a fractional distillation, we are separating the two miscible liquids.
Yeah.
But simple distillation, we are obtaining a liquid from a solution. or liquid from hydrated salt. So we don't need a lead. We use a distillation method.
So, sir, when we have a crystalline salt, we can just use crystallization to obtain salt and water.
If we have what? If you want
If
a
we have a crystalline salt,
no salts are crystalline or salts are amorphous. Like if you have a soluble, like if you want to obtain a salt from the solution, you can use evaporation or crystallization. If you want to obtain a soluble salt, like salt solution is there and you want to obtain a salt from that, in that case you can use a crystallization.
so sir, this nickel sulfate 6 water is not a solution.
It is a solid here.
Solid.
It
Okay.
is a hydrated salt. So hydrated, like when I say I have hydrated copper sulfate, it does, because these 6 molecules are not able to dissolve the sodium sulfate, so it remain solid. Actually what happened, they trap the water molecule. So 6 water molecules are trapped or attached with the structure,
With the lattice, yeah, got it.
with the lattice. So it is a solid which trap water molecule and we want to obtain that or extract that water out. So what we will do, this is not the full apparatus, we will supply heat. When we supply the heat energy, the water, the hydrated nickel sulfate turn into anhydrous nickel sulfate and the water will turn into vapor and escape. But we want that water, we want to collect that water. So to cool down the water vapor, what we will do, we will use a Lybric condenser. The water inlet and outlet are always important. And here it is close. You can place a thermometer because the thermometer can be used to show that you're obtaining, if you reach 100 degree, it means that you're obtaining a pure sample of water. You can check the boiling point. Water inlet is there and water outlet, and you have a beaker. So when these water vapors will rise, these water vapor will condense, cool down, turn into liquid state, and you will collect water. And what is the test for the pure water? How you can check pure water? You can test with the boiling, because they are not saying presence of the water, they're saying show the presence of, term pure is used. So if you want to test a pure water, the only way you can check the boiling point. But if they say show the presence of the water, then you can use anhydrous copper sulfate or you can use anhydrous cobalt chloride. So the points which you will include, basically what we will do, we will heat the last question of all paper 6. You will find planning of experiment, and it is better, it's not always that you have to draw, but most of the questions you have to draw. Last question of paper 6. So we will heat. How we will heat, you can mention the apparatus, because it's the best answer is when you're mentioning the name of the apparatus. So what apparatus you can use, you will heat the solid by Bunsen burner or salt by burner or Bunsen burner. Then use condenser to cool down the vapor. Then how to the check, and what will happen, because as the water is removed, the solid nickel sulfate will show a color change, because hydrated salt and anhydrous salt have different colors. So the salt will show a color change. Then check the boiling point, and it will boil at 100 degrees centigrade. Is it clear? This experiment in which we plan to obtain the water from hydrated nickel sulfate, not a solution of a nickel sulfate, it is hydrated nickel sulfate. So in this question, agri-limes are mixture of calcium carbonate and calcium oxide. Farmers use agri-limes on fields to neutralize acidity of the soil. Plan an investigation to find out which of the two agri-limes, Q or R, will neutralize more acid. You are provided with a common lab apparatus chemicals including dilute nitric acid. So these are the chemicals available and you want to plan or you want to identify which of them is requiring greater amount of, because which of the two agri-lime Q and R will neutralize more acid. So how you can work out, basically, again, when acid and base are reacting with each other, you can use phenolphthalein, you can use the titration method, and it contains both calcium carbonate and calcium oxide. So when calcium carbonate is there, it means you will see the bubbles. Once all of the calcium carbonate is used up, no more bubbles will form. But for a fair comparison, what we will do, we will take equal masses of agri-lime Q and R. First I'm explaining and then I will write. So first we'll take equal masses of agri-lime Q and R. Then from the burette, fill the burette with dilute nitric acid up to 0 mark. Both are filled with nitric acid. And then add nitric acid because it contains calcium carbonate as well. So you will see bubbles. How you will know that all of the agri-lime Q or R is reacted or completely reacted? So no more bubbles will be there. Or what else you can add? Here you can add an indicator as well. So you can also use an indicator when the indicator will show a color change, because when you are adding an acid here, the acid is reacting. So there is no more acid present. Once all of the agri-lime which contain calcium carbonate and calcium oxide reacted, you will not see, you will observe a color change of indicator, because in indicators have different color in acidic and alkaline medium. That time you will stop and you can measure the volume of acid required for completely reacting with agri-lime Q and agri-lime R, and compare the volume. The one which need greater volume for acid, the one which required a greater volume of acid, it means that is can neutralize greater amount or more useful. This is one way. There's also another way. So what we can do, so we can measure the mass of measure the mass of agri-lime Q. First we measure the mass and then we will add to known volume of acid. And continue to add, or measure mass of agri-lime is there. We did not add all completely. Add to a known volume of acid which is having indicator, and continue the process until the indicator show a color change. And then repeat with agri-lime R. Now, example, if I say I have two containers filled with the same amount of acid. So equal amount of acid is there in the two containers. In the first experiment, I add agri-lime Q. In the second experiment, I add agri-lime R. For this 10 cm cube of nitric acid with indicator, example, I need 2 grams of agri-lime. For this 10 cm cube of nitric acid, I need 5 grams of agri-lime. So which agri-lime is better, Q or R, for neutralizing the soil, acidity of the soil? So Q is better because a small quantity can neutralize the same amount as compared to R. So at the last, you can mention your conclusion, the one which required a small. You don't have to say Q is better than R or R is better than Q. You just have to write a journal conclusion and mentioning that the one which required less or smaller quantity of agri-lime, it means that is useful or better. In this, metal ring can be coated with a layer of a copper using electricity. Plan an experiment to electroplate a small metal ring with copper. You are provided with a common lab apparatus, a copper rod, a copper sulfate solution.
Electrolysis.
Yeah, we'll use electrolysis. So you have to draw electrolytic cell. So first a container. You don't have to write any equation. You don't have to say what happened to ions. Yeah, we will dissolve copper sulfate, make us copper sulfate solution. So we have aqueous copper sulfate, which is blue in color. Then a copper electrode, which is anode, and the ring which we want to electroplate, that ring is cathode. Then connect the terminals of a battery. It should be labeled anode, cathode, and this is the electrolyte. So when we will pass the current, what happens? The copper ions from the solution will move towards the cathode, and copper atom will go inside the solution as a copper ion. But you don't have to mention all this detail, just the experimental setup. Experimental setup means like what you connect with cathode, what you connect with anode, where the positive terminal is, what is connected to positive terminal, negative terminal, what electrolyte is made up of. So first, when we want to electroplate anything, the surface should be clean. Here we want to electroplate a ring, so ring surface should be clean. How I can rub the metal surface? Rings are made up of metal. So we can first clean the surface of ring by sandpaper. That is first thing. Then after cleaning the surface with a sandpaper, we will dissolve copper sulfate in water or make a soluble salt solution. Then we will connect the positive terminal of the battery to copper rod and negative terminal of the battery to the ring. And then, because for a uniform plating, when we switch on the supply, for a uniform plating, we should we should continuously move the ring so that it will have a uniform layer, and then we will remove the ring.
Sir, should we write any equations?
No equation for this. You don't have to. There is equation, but not equation. You don't have to write an equation. This is a paper 6 question in which experimental procedures, experimental techniques, naming the apparatus is important rather than the equation. Wash with distilled water. And dry with tissue paper. That is a experimental procedure how you can electroplate a ring, a metal ring. Is it clear, this experiment? Any doubt in this? Then another experiment from winter 16, paper 6, variant 3. Always you will find the last question is planning of experiment. Okay, in this question, a liquid cleaner is a mixture of 3 substances. So there are 3 substances present in a liquid cleaner. And what are these substances? Water is there, which is having a boiling point of 100, sodium carbonate, which is solid and soluble in water. And silica is also solid but insoluble in water. Plan an experiment to obtain separate pure samples of each substance from the liquid cleaner, from the mixture in the liquid cleaner provided with the common lab apparatus. So you have the common lab apparatus and you want to plan an experiment to.
Sir, we can boil water and condense it by simple distillation.
Okay.
And then we will get water and silica.
But if you do carry out simple distillation, then first thing is we have a mixture. So first what we will do, like the cleaner is there, first we will filter it. Why we will filter it?
Yeah, to get the silica.
Yeah, because that is insoluble. Or what you can do, you can add water and then filter. So the steps which are included to obtain silica: what we will do, we will filter. So when we filter it, and wash the residue, residue is actually a silica, and dry the residue, how you with tissue or the filter paper. That is, we obtain silica. The second thing is we want to obtain water. So how to obtain a water? We will heat the cleaner or the filtrate basically. which in the first experiment part is done, and then use condenser or condense the vapor.
Fractional distillation here.
No, it's a soluble salt is a sodium carbonate from water, simple distillation.
Yeah. Okay, got it.
So condenser is there to cool down the vapors. And then the last one, sodium carbonate, because now what you have sodium carbonate is there as the second technique is done. If a liquid, like if any other thing is not there, only water is there, silica is there, and sodium carbonate. So when you are obtaining or heating the mixture, water will be removed, and what you are left with, we will continue heating it, or we will heat to dryness. Dryness means like no more liquid is left behind, and the solid will be sodium carbonate.
Sir, the boiling point of how will we know the boiling point of
Sodium
sodium
carbonate
carbonate?
is solid. Sodium carbonate is a soluble salt. Salts, when they are in, they have high melting point. Even you're supplying
Yeah,
heat
got it.
energy,
Yes.
it won't melt. Like it will not. There are some solid which can decompose on heating at low temperature, but group one salts, they have high melting point. So these are the steps to obtain silica gel. Sorry, not silica gel here. Silica only. Silica gel is also used as a drying agent. So, but here we are using a silica or silicon 4 oxide or sand from water and sodium carbonate. Is it clear, this question? Any doubt related to the class today?
No, sir, everything clear.
Okay, so I'll end the session and share this with you. And don't forget to submit the weekly homework. Some of you already submitted, but submit it before the class and mention your doubts during the class for discussion.